This is a few experiments with a couple of simulators about light polarization for physics in everyday life and conceptual physics. I'm starting with the O physics polarizing filter simulation that was linked in the announcement and in the lecture. And it asked about the direction of the electric fields in the light after it passed through the first filter and then through subsequent filters. So right now, we are showing three openings after the very first filter. I'm going to simplify it for now and just take it back to one, but then we can turn on some others later and show a fun effect. So if I start playing the simulator, again, this is trying to give us a representation of perhaps the direction of the electric fields that are part of the electromagnetic waves within visible light. And so what the artist tried to do here is show that the electric fields are in many directions prior to moving through filter number one, but after passing through filter number one, all of the electric fields that are transmitted are in a single direction. So this first polarizing filter actually cut off part of the light. And if I'm polarized in the vertical direction passing through here, and then I go through a second polarizing filter that is also vertically polarized, all that light is actually transmitted. But if I rotate, and I'm just going to rotate to 90 degrees to start, all of the light is essentially blocked by the second polarizing filter because, as you can read about in the text, the molecules within the polarizing filter are acting like tiny antennae, absorbing the electric field and then re-emitting it in a new direction. And if I have these two antennas that are at 90-degree angles to each other, the system doesn't work. But if we go somewhere in between, I do get a portion of the light that is then transmitted after the second filter, but it has now been repolarized in a new direction. And so if I had the ability in this simulation to measure intensity, I'd have 100% intensity over here. I'd have 50% intensity over here because only half of the light makes it through filter number one. And then the intensity I would measure in this region would depend on the angle of this polarizing filter. But I want to show you a fun effect that demonstrates that this light is polarized, repolarized by each filter. When we do this actually in the lab, we can pull out some actual polarizing filters, right? So no light is coming through filter number two right here, but I'm going to put in a second filter and actually three filters, I guess, in the stream overall, get more light to pass through. So here again is filter one, and filter 2 is lined up with filter 1. So filter 1 doesn't do anything to the light, and it's all blocked by filter, or it's all passing through filter 2, and then it's all blocked by filter 3. But watch what happens as we rotate filter 2. Some fraction of the light that gets through filter 1 now also gets through filter 2, but it gets repolarized at this new 45-degree angle. And now, because the angle between filter 2 and filter 3 is not 90 degrees anymore, some of the light that passes through filter 2 gets transmitted through filter 3 and again is repolarized in the direction of filter 3. And so this is an odd observation that, two filters blocks the light entirely, and if you put a third filter in at certain orientations, you actually allow some of the light to be transmitted. But this is one of the experiments that can demonstrate for us the wave nature of light. I also found a second simulator on this website, and they want you to subscribe, but they do say they're going free during the COVID crisis. You don't actually have to subscribe to play with the simulator as long as you're fairly quick about it. So here's the simulator, and I'm going to load it up again. And it gives you like a minute before it pops up with that little subscription screen. And so here is my polarized light source. And in this, it's showing actually a type of polarization called circularly polarized. So you can put this little filter here and see that the electric field is moving around in a circular direction. But after the first polarizing filter, all these little antennae in the first polarizing filter now create it polarized, in this case, in one direction only. And right now, polarizing filter 2 is oriented so that none of that light is getting through. But as I change polarizing 2 filters angle, I have to subscribe. No, I don't. If you change polarizing filter 2's angle, more and more of that light gets through as those filters come into alignment or as those tiny antennae line up in such a way that more of the electric field portion of the electromagnetic wave is transmitted. So that's what we wanted to see, and hopefully a couple of those simulations help you visualize the phenomena of polarization you can read about in the Bloomfield text.